In the last lesson, the third one of lesson 3, we're going to do the work in worksheet L3 of a file, Excel file that we named lesson underscore unit 3 underscore your last name. Mine's SNAR. I use SNAR, you use yours. Okay. Now in this problem, the owner of a circuit board factory is a vendor to several video game manufacturers. The analyses indicate that the circuit board it produces for video game controllers lasts an average of 4.4 years. So X here is time. And the probability of their failure during a given interval of time is independent of how much time has already elapsed without a failure. With the standard deviation of time until failure equal to 4.4, the owner of the circuit board factory rightly concludes that the distribution of time until failure is probably what? Now, of these choices, it can't be binomial, it can't be Poisson because these are discrete, and here time is continuous. The fact that the mean is equal to the standard deviation and you have this independence property means that the distribution that probably is the most appropriate here is exponential. We're going to fill out this table down here to answer these questions, like we did with the normal distribution, right? I'm going to copy this table. I'm going to paste it, and then choose match destination formatting. Okay. Mean of the distribution is 4.4. The standard deviation is 4.4. And 6 is blank standard deviations above the mean. Okay, so what we're asking for here is the z-score. And the z-score, if you remember, is the value 6. That's the value of the observation x, right? Value of x, in this case 6. 6 minus 4.4, that is the deviation in the mean. 6 years minus 4.4 years is 1.6 years. We're going to divide that by the standard deviation, which is in years as well. So we got years divided by years. So that means the z-score is unitless. And we need 4 decimal places. So the z-score is 0.3636. It's positive. The reason why it's positive because 6 is greater than the mean, right? 6 is greater than the mean. So that's why the z-score is positive. What is the probability that your circuit board lasts less than 1.9 years? Now, an exponential distribution looks like a chi-square distribution. It looks like it. It has the same general shape, right? When it's got 1 degree of freedom or it's got 2 degrees of freedom, that's what an exponential distribution looks like, right? Now, to calculate the area under the exponential distribution, you use 1 minus e raised to the minus t divided by mu. Mu is our mean or standard deviation. Sometimes you'll see this as minus t times lambda. And lambda is just 1 divided by mu, the mean, right? This function draws out that curve, and this function computes that purple area. To do this for a normal distribution, we did equal norm dot dist. Well, we're not going to use norm dot dist. We're going to use this. So you can think of this as expo dot dist. This right here, right? Okay, so the first thing we have to do is we have to calculate the probability that x is less than 1.9. So out here I'm going to type x1 equal, right? x1 equal, and I'm going to do 1.9. Let me do this. I'm going to change these to yellow boxes with, these are going to be our answers, right? So I have to use this function to calculate the probability of being less than 1.9, right? So equal 1 minus, now to do the e to some power, you type exp and then parenthesis, right? And then minus t. In this case, 1.9, right? And then we got to divide by the mean. So this is equivalent to typing equal norm dot dist, right? And you enter a value from the number line, in this case 1.9, and you enter the value for the mean, in this case 4.4. And then you'd put comma 1 for true, right? Let me change these to 4 decimal places. Okay, so the first one, the probability of being less than 1.9 is 0.3507. That would look like is this right here, right? So if I put in 1.9, this area would be 0.3507. Now, because chi-square with 1 degrees of freedom and this exponential distribution have two different shapes, this is going to have a probability of value of 0.832. Our problem is going to have a probability value of 0.3507. You want to calculate the probability that your circuit board lasts more than 1.9 years. Okay, so if this is the probability it lasts less than 1.9 years, the probability that it lasts more than 1.9 years would be 1 minus that value, right? So we type equal 1 minus B4. And notice that these two values added together equals what? The values added together equals 1, right? So this is the probability of being greater than 1.9. Now, graphically, what does that look like? Well, we just do the right tail instead, right? If this area were 0.3507, this area here would be 0.6493. Now, what is the probability that your circuit board lasts exactly 1.9 years? Okay, so let's go to the graph here. So here's our distribution, right? We want to know the probability that your circuit board lasts exactly 1.9 years. Now, for any continuous distribution, the probability that x, or in this case, t, equals a given number, that's 0, right? So if we go up straight up from 1.9, right? And the reason why that is because the width of this rectangle, right, is 0 because it's a line at 1.9. That rectangle would have 0 width. 1.9 minus 1.9 would be 0, right? And 0 times that height would be 0. So this value here is 0, right? So this would be 0. So x here is less than 1.9, or x is greater than 1.9, right? That union is 1. Remember, we add the probability values together because they're mutually exclusive, right? But what's the intersection of x less than 1.9 and x greater than 1.9? If the union is 1, then the intersection has to be 0, right? Now, on average, how long would 5 gaming controllers with the company circuit board in them last if they're used one after another? Assume they are discarded when they break. One's going to last 4.4 years, right? So if this question was on average, how long would one gaming controller last? That'd be 4.4. If this were how long would 2 gaming controllers last? That'd be 4.4 plus 4.4. We're to multiply this by 5, right? Because we're going to 4.4 plus 4.4 plus 4.4 plus 4.4 plus 4.4, or 4.4 times 5, right? So that should be 22 years. 95% of your circuit boards will last at most how long? So what are we asking for here? We're looking for the 95th percentile, right? How do we find the 95th percentile? Well, up here, we use what? We use this function here, right? We use this function to get that value. The 35.07 percentile is 1.9. Here, the box is 0.95, right? So the cell equals 0.95. What does that equal? It equals the stuff inside this box here, right? So that were 0.95, right? It would equal this, correct? And what is E4? E4 is the thing we're looking for, right? So this would be like the X that we want to find. And then B1 is our mean, right? 4.4. So we're dividing by the mean. If I know what X is, right? And this equaled 0.95, this would be the 95th percentile. So we have to solve this for X. So the first thing we're going to do is going to add this to both sides of the equation. And then what are we going to do? We're going to subtract this from both sides of the equation, right? And then what are we going to do? Well, this right here is E raised to this power here, right? How do we solve for X when we got it in the exponent of this natural number E, right? These two things are identical, right? These two things are identical. So I'm going to change this to E raised to some power, right? Okay, so what we're going to do here is we're going to take the natural log of both sides. Take the natural log of both sides. So we have ln, right? I'm not going to do the arithmetic here, and I'm going to show you why in a second. Now, the natural log of E raised to some number is just that number, right? Okay, now what I got to do is I just got to multiply both sides by 4.4. Right? And then I'm going to multiply both sides by -1. So -1 times -x, well, that's just x, right? And then I get a -1 times this whole thing is negative, right? I'm going to copy that. The equivalent of this in the normal distribution would be norm.inv, norm.inverse. With the probability value being fed into it, 0.95, and the mean being 4.4, and the standard deviation being 4.4. So we're going to put that right here. We're going to type it equals natural log. This right here is, we want the 95th percentile. So I'm going to change that. I'm going to click on this. Right, I want the 95th percentile. And this is our mean, 4.4, right? So again, this is equivalent to norm.inverse, parenthesis, we click on a probability value, comma, we click on the mean, comma, we click on the standard deviation, right? That's what this is equivalent to. And we get 13.1812. So if we go back to our thing here and I do a p-value of 0.95, right? If this were my exponential function, right? Exponential probability distribution, right? And this for 0.95, this value here would be 13.1812, right? Now, what is the probability that your circuit board lasts at least 6 years? So it lasts 6 years or more. So on this, we're going to calculate the probability that X is less than 6, right? So I'm going to copy this. I'm going to move this down to here. right? And I'm going to change this to 6. So if the number on the number line is 6, the probability of being less than 6 is 0.7443. But I want to know the probability greater than 6, right? So all I have to do here is 1 minus that value. Those two add up to 1. Okay, now I have two values of x, right? I got 6 and 3.4. Okay, so I need two probabilities here. So what I'm gonna do is I'm gonna add, insert a column, right? Okay, so what I want to do here is I want to calculate the probability of less than that and the probability of less than that, and then I'm gonna take their difference, right? So this one, I want the probability that we're less than 6, right? Which again is 0.7443. And I want the probability that we're less than 3.4, right? So the probability of being between 6 and 3.4 is the difference in these two cumulative probabilities, right? So this goes here and this there. So that's the exponential distribution function.